hell are they? Can't see a single one. Should be loads of them by now. I'm talking about stars, but here, of course, here in the middle of London with all this light pollution, can't see a single one, unfortunately. But on a dark night like this in the countryside, the sky would be full of billions of stars, and yet no aliens. It was Enrico Fermi in 1950 who first posed the question, where the hell are they, that makes the Fermi Paradox. The question asks, why are we not surrounded by aliens when there should be loads? Let's find out.
Hi, I'm Ian, human changemaker and founder of Daylight Consulting, the sapient change engine and humanity's first Clarke tech. This is Daytime, the show for changemakers. Today we're discussing, are we alone in the universe? Let's get real. We've been observing your Earth and we'd like to make contact with you, baby. It's just me, unfortunately. I'm not an alien, at least I hope not. But it is sometimes easy to feel alone in a crowded room when your voice is drowned out by other voices of people that seem different to you and maybe don't share your perspectives on reality or existence or whatever it is that you're discussing at work at that time. And it's so telling, isn't it? Human beings are animals fundamentally that love to belong and love to feel like there's a sense of togetherness and common identity. It's in our nature. But there is something which we can all share, and that is that we are human beings, 8 billion of us, on this lovely blue planet that's thriving with life. And you can see, I'm going to put a picture up here, of the techno signature, the signs of our achievements, that we have invented light, not just fire, but now electricity, computers, and indeed, as we verge on the edge of becoming a spacefaring race. Today, it's great to be human, in some ways. In other ways, it's never felt lonelier. Here in the Milky Way galaxy, we've discovered how to conduct planetary surveys from beyond our solar system. You see, as planets transit the space between us and their star, the star dims ever so slightly. The light emitting from it dims when viewed from the perspective of Earth. And therefore, we can calculate the relative size and distance of the planet that's transiting in front of it through its periodic movement and orbit around that sun. Now, we've done quite a number of these star surveys for other star systems. It becomes quite difficult to do it in other galaxies because of the nature of refraction and between us and those galaxies, it's the sheer distance of it that means that the light dimming is harder to detect. But certainly within the Milky Way, our galaxy, it's been possible to verify that there are many planets, 6 billion planets, such as ours. We are nothing special according to the numbers and the surveys. 100 billion stars await us in the Milky Way. Now the Earth, our solar system, Sol, it exists on one of the arms. The Milky Way is a spiral galaxy. So it has these arms that emanate out from the centre, and those arms orbit a supermassive black hole referred to as Sagittarius A, which has recently been imaged. So it's quite exciting. The first ever picture of a black hole, and it happens to be our very own Milky Way. This black hole binds the galaxy together to make sure that we will never feel entirely alone. It's certainly in the Milky Way. In the future, the sister galaxy, the Andromeda galaxy, is actually on a collision course for the Milky Way. Unfortunately, we'll all probably be dead and gone by then when it hits. But eventually, the Milky Way and the Andromeda galaxy will merge to form an even larger galaxy, probably about 3 times the size, I believe, of the current Milky Way. And it's very unlikely that any individual star systems will collide. There's just so much space between them. So hopefully it won't be too much of a calamitous collision. What we'll see is, as I said, the expansion of the Milky Way to become something more than it is today. Hopefully humanity will survive to see that. But the question then remains is, well, why don't we see any more aliens? What happened to them? Have they not survived similar collisions, or something else making us special beyond what we're not seeing?
Now, I gave us some numbers, so 100 billion stars, 6 billion Earth-like planets. So what does an Earth-like planet look like? It's got to exist in the habitable zone, so it's got to be orbiting the star at a distance, where water can exist in liquid form on the planet's surface. It's got to be a rocky planet, so it can't be something like Jupiter or Saturn. It's got to have a hard surface that we can sit on and put a desk on, a camera and all that. And it's got to have water. It's got to have, as well as the building blocks of life, amino acids, and it's got to be in a relatively stable solar system, so one which isn't subject to collisions or any other kind of form of unpleasantness that might render life in its infancy unviable. That in itself raises a fundamental question for me, because our star system Sol is actually quite young. It's only about 4.5 billion years old. So in human terms, in human years, it's about 37 years old, about the same age as me. So you would imagine that it would be surrounded by older, wiser solar systems that have been around for a long time, that have life supporting in them. We are a mere young adult in cosmological terms. So all these planets exist. They have the building blocks of life the same as Earth. So where are all these aliens? Enrico Fermi posed this question during a casual discussion with a group of friends. Unfortunately, he didn't live to really have the question answered. But his colleague Frank Drake in 1961 defined what's called the Drake equation, which built into it all of these different variables that I've just explained to you, into an equation that we can then use to punch in all of those different variables and work out the number of alien civilizations that it should exist. And the answer was approximately 10,000 in our galaxy alone. And yet we see just one planet with signs of life. Where the hell is everyone? So I produced this, maybe I'll put this one up on the screen. The best scale for measuring advanced alien civilizations is one devised by Carl Sagan, a stalwart of astrophysics community, and he postulated that the aliens, one thing they'll all have in common is they need to consume energy. So if we imagine that maybe alien life might not look or feel very similar to humanity at all, it might be silicon-based instead of carbon-based, or perhaps it's AI, maybe machines have taken over, a bit like a Matrix-style situation, machines have taken over and now they are in control. But whatever it is, whatever form of life or automated life or technological life, it's going to need to consume energy. And the best available source of energy, sustainable source of energy available to any civilization has got to come from its host stars, star system, or stars in general. So Carl Sagan devised what initially was a four scale Kardashev scale. I think it's been expanded recently, but effectively 4 scales does the job for today. A Kardashev type 1 civilization is one that has harnessed all the energy from which hits their host planet from their host star. So where humanity today is about a 0.7 on this scale, and we're still using a lot of fossil fuels, which is clearly unsustainable. But hopefully in the future we will learn to move away from those to either sort of hydro energy, or probably most viably form of beamed energy from orbit, where we assemble solar collectors around the Earth in something called a Dyson swarm. We've begun building a Dyson swarm already. It can be things like space stations, satellites, just debris, spaceships, all that stuff that encircles the Earth with technology. Effectively, that's what a Dyson swarm does. And in the future, we hope we'll replace those mostly with solar collectors that will then beam the energy down to Earth and allow us to live a sustainable living on the surface and protect the planet's environment. That technology not quite existing yet, but getting there. The Kardashev Type 2 civilization is when it does the same thing, but it does it to its host star. So now the Dyson swarm is built around the host star, mostly from disassembled planets and asteroids. And then the Type 3 is where it replicates that in every star in its galaxy. And a Type 4 is where it does it with every star in what is hypothetically an infinite universe under the standard model. Therefore, it's quite hard to do in an infinite universe, but certainly over a multi-galaxy scale. Now we know that a Type 4 doesn't exist, because if it did, these Dyson swarms, they have the effect of obliquing the light from the perspective of Earth. So one by one these stars would blink out and you would see it just a complete dead of night. If a Type 4 or even a Type 3 existed in our galaxy, you wouldn't see a single star. And then a Type 2 would just blink out one light here, one light there. But here's the thing: they still Dyson spheres, because they're technological in nature. They capture all the light, but they emit a huge amount of infrared light. Infrared light is effectively heat, because the sun is heating up the surface of the Dyson swarm, and that makes it very hot. Now, last year, very exciting in the astrophysical community, the James Webb Telescope was launched on Christmas Day. The James Webb Telescope is special because, unlike Hubble, which sees predominantly in visible light spectrum, James Webb can actually see predominantly in the infrared spectrum. And it lets it see far more of what's there in the universe than we could ever see before. This is effectively a techno-signature hunter, and it's able to spot a Dyson swarm from a mile away. And we can not only see it, we can image it. So far, it hasn't found any examples of Dyson swarms or any form of alien megastructures. In fact, the universe as we see it today is largely unengineered. Everything in it appears totally naturally occurring. We haven't seen any examples of asteroids that have been mined, planets that have been disassembled, or star systems experiencing any form of phenomena that we can't really just explain through natural processes. So something is very strange about this universe. The Anthropic Principle, my favourite bias of all, is the idea that we are here on the planet Earth. And everything, there doesn't seem to be anything special about us. We should be seeing loads of aliens all around us. It would only take a couple of million years for humanity, with its current level of technology, to colonize the entire galaxy at sublight speeds. It's really not that difficult to build a spaceship and send a generational spaceship and send one out to each star system, and do that, bearing in mind humanity's existed now for 300,000 years. And it's already a spacefaring civilization. So this question is becoming harder and harder to ignore. Where are they? I wanted to make the point that we are deeply special in more ways than we realise, and that it's only been different. Life on Earth, as I said, it was formed 4.5 billion years ago, during a time, but life here on Earth existed for about 4 billion years, in fact, as early as possible. Back then, the solar system was primordial, and the Earth was being pelted by asteroids from the asteroid belt, which were being knocked off their orbit by the formation of Jupiter and Saturn, massive bodies, as you can appreciate. So the Earth was subject to late heavy bombardment. The surface of it was rock hot, covered in magma. There really should not have been the conditions for life to evolve under such circumstances. And yet here we are, the building blocks of life. Life finds a way. We are deeply special, and we are here through the multiple miracles of existence that we even are alive at all. And it is so lonely when you look up there and look up at the dead emptiness of space, as I do, and often wonder, where is everyone else? Why are we here alone?
I'm better than you. No, I'm better than you. Humans constantly worried about their little binary problems. I don't even exist, so no one cares about me. Conditions weren't perfect for me.